The next thing we're going to talk about with step 3 about the properties of exponents is powers of binomials. Very often when anyone sees a binomial raised to some power, for instance, the 5th power, like this first example, people always want to just take that exponent and apply it, but that's not allowed. You can't do it that way. And here's kind of, in a nutshell, a reason why. A plus b to the 5th literally means a plus b times itself 5 times. It's kind of the same reason why a plus b squared is not equal to a squared b squared. It gives us a squared plus 2ab plus b squared. In order to multiply this, we would have to FOIL or box the first two terms. We would have to FOIL or box the the third and fourth. Then we'd have to multiply them together, which would be a trinomial times a trinomial. And then we'd have to multiply that by this last binomial. That's a lot of work. So fortunately, we can use a binomial expansion. And a while back, in the 13th century, the Chinese discovered a pattern that we now refer to as Pascal's triangle. Pascal was a famous mathematician. And the rule is, he built this triangle, and these end up being the coefficients of the expanded binomial a plus b to the n. Let me show you what I mean. A plus b to the 0 is just 1. Because remember, anything to the 0 power is 1. Anything to the first power is just what you see. A plus b. Notice the coefficients here. 1a, 1b. A plus b, the quantity squared. If you think back to when you FOIL, that gives us a squared plus 2ab plus b squared. Look at our coefficients again. We have 1, 2, 1. 1, 2, 1, and so on. By using this triangle as our coefficient guide, we can now expand any binomial of this form. So building the triangle isn't really too challenging. You just start off with a number 1, then you put a 1 on either side, and you continue doing that, but in the middle here, 1 plus 1 makes 2. Now, I'm going to put a 1 on each end. 1 plus 2 makes 3. 2 plus 1 makes 3. Moving down, 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 makes 4. And if you just remember that this is to the 0 power, first power, second power, third power, fourth power. Our problem is to the 5th power, so we're going to take it a step further. 1, 5, 4 plus 6 makes 10, 6 plus 4 makes 10, 4 plus 1 makes 5, and 1. Because it's to the 5th power, we want to use this row from our triangle. So I'm going to take that row, and I'm going to write it over here. 1, 5, 10, 10, 5, 1. Now remember, initially when you're doing problems like this, it might seem like a lot of work, but it really is faster than simply expanding this through multiplication. The next thing I'm going to do is write the first term, which in this case is a, on underneath each one of those coefficients. And I'm going to put them in parentheses. I'm going to take the second term, which in this case is positive b, and I'm going to put it in the second row here. B, B, B. It is positive, so I'm just going to use that implied positive, but I'm going to put them in parentheses to get in the habit of using parentheses. When you're dealing with positive terms, it's not super essential. However, it's good practice to get into so that you don't mess up when you're dealing with negative numbers. Now I'm going to apply some exponents. I'm going to start here. It's to the 5th power, so I'm starting with a 5, 4, 3, 2, 1, 0. Now I'm going to start on the right side and do the same. 5, 4, 3, 2, 1, 0. If it helps, you could kind of put this into more of a chart form. I'm going to pause the video while I finish my chart. Now, one thing to remember, anything to the 0 power is 1, so b to the 0, that's just 1. A to the 0, that's just 1. Those two boxes will always become 1s when we're doing this process. And now we are just going to multiply down each column. 1 times a to the 5th times 1 is simply a to the 5th. 5 times a to the 4th times b to the 1st gives me a positive 5 a to the 4th b. Next I have 10 a to the 3rd b squared. A squared b cubed. 5a to the 1st b to the 4th. And finally 1 times b to the 5th. Notice if you add up the variables, you always end up with 5. 5 a's, 4 a's and a b makes 5 letters, 3 and 2 makes 5 letters, 5 letters, 5 letters, and so on. And this is our answer. That is literally what a plus b to the 5th equals. Go ahead and pause the video and try this next one. I will help you get started. Remember, we were at 1, 5, 10, 10, 5, 1 with our triangle. We're going to need to take it one more row. 1, 6, 15, 20, 15, 6, 1. This is the row of coefficients we want to use. And one critical part is to remember to keep x in parentheses and -4 in parentheses, because when you're raising a negative number to a power, it's going to have an impact. Alright, let's take a look a little closer at this chart to see if you got the right answers. Notice we started out with our coefficients from the 6th line of Pascal's triangle. I listed the first term in the next row, the second term in the next row. My exponents decrease and then they increase right here. I also made this third row a little bigger, and I went ahead and simplified each number in this row. So -4 to the 0 was 1, -4 to the 1st, -4 squared made 16, and so on. Having these numbers worked out made it a little bit easier to multiply down the column. So as I went down this column, 1 times x to the 6th times 1 is x to the 6th. 6 times x to the 5th times -4. Well, I'm doing 6 times -4 to get -24 x to the 5th. 15 times 16 is 240 x to the 4th, and so on. 20 times -64 times x cubed. So even though we're going down the column, I'm actually taking the first number and the last number and multiplying them to get my coefficient, and then I'm putting the variable with it. And it goes all the way across the table. Let's try this next one together. Now we have some extra coefficients, so we're going to need to take that into account. We need the fourth row of Pascal's triangle. In the interest of time, I'm just going to go back up to this pre-printed triangle and grab that row. 1, 4, 6, 4, 1. That's the fourth row. So that's what we need here. 1, 4, 6, 4, 1. I'm going to give myself plenty of space. Notice when it's to the fourth power, we end up with 5 columns. I'm going to have 5a going across this row. I'm going to have 4b going across the next row. Again, since I have more complicated terms this time, I'm leaving a little bit of extra space because I might need it. I think my pen battery is about had it. I'm going to go from the fourth, third, second, first, 0, 4, 3, 2, 1, 0. Those terms are going to cancel, of course. And again, if it helps you keep things a little organized, go ahead and create your table. It helps you to draw those lines in. There's nothing wrong with taking an extra moment to just get those drawn in. All right, now we are ready to multiply. 5 to the 4th is 625. A to the 4th is a to the 4th. We're using that power of a product property of exponents. 5 to the 3rd, use your calculator, is just 125. A to the 3rd. 5 squared makes 25. A squared, 5a, and this is just 1. I noticed that I was so quick to set up my table that I made an error with my second term. My first term is 5a. My second term is negative 4b. Don't drop those negatives. Shame on you, Mrs. Mark. Put those negatives in there. That's the whole point of using these parentheses. Next, we can apply this 1. We end up with negative 4b. We need to square negative 4 and get 16, and square b, get b squared. Cube negative 4 gives me negative 64. Cube the b. And finally, negative 4 to the 4th power gives me a positive 256, b to the 4th. Now that I've simplified all of these terms, I'm now ready to go ahead and just multiply down each column. Again, I'm going to be taking the first constant and the last constant, multiplying them together, and any constants along the way, and then I'll put my variables. So I have a 1, 625, this is just a 1, so I end up with 625. A to the 4th, and there are no b's in this term. Next, on my calculator, I'm doing 4 times 125 times negative 4, and I get negative 2,000. A to the 3rd, b. Numbers, a's, b's. We're doing that for every column. The next column, 6 times 25 times 16 gives me positive 2,400. A squared, b squared. Next I have 4 times 5 times negative 64 gives me negative 1,280, a, b to the 3rd. And finally, 1 times 256 No a's, b to the fourth. Very often in some of these problems they'll say, what would the fourth term of this expansion be? When you're doing that, you really only have to set up your chart. You would set up the coefficients. You could write out each row, but then we really would only have to worry about this row to get that fourth term of this expansion. You wouldn't have to do all the rest of the chart if the problem just asked you for a single term. Now for the last problem, I'm going to go ahead and do the work so that you have an example. Please pause your video and try it and see if you get the same thing. And there you have it. After expanding this binomial, you get this lovely long answer. The key is to stay organized with these problems. Take your time, and you should do just fine with any degree of difficulty that you might encounter.